Hello, my name is Ravi Vardarajan and I am the Senior Country Technical Manager for Dassault Systems SolidWorks India and SAARC countries. Today I am going to take you to this presentation of SolidWorks, your bridge to the industry. First we will look at what are the industry challenges and what are the different industry verticals which face these challenges, and how does SolidWorks basically help you to bridge this gap. That's what we're going to look at in this presentation. Let's move on. So what are the industry expectations? One is the design for manufacture, design for least weight, design for least cost, design for form, fit and function, reduce design cycle time, design for least environmental impact, fail-proof design, virtual simulation, reducing physical prototypes, optimizing the design, design that is too complex to do using hand calculations, and above all, communicating all this design to the other people in the enterprise. So which are the industry verticals has these challenges? All industry verticals what we know. One is aerospace, automotive segment, heavy equipment, machinery, industrial components, mold, tool and die, electronics, medical equipments, consumer products, green energy, power and process, scientific equipments, shipping, and all other industry segments has these challenges. And of course, the design and engineering services, which is offering all the services to these industry verticals, also have these challenges. So every industry segment, what you can think of, has all the challenges what we discussed before. So let's look at these challenges one by one. One of the design challenges, design for fit and function. You would have learned in your academics how to give tolerances. You would have learned about different types of tolerances like running and sliding fits, location and assembly fits, and transitional and interference fits. Some of the fits you would have learned like press fit, dry fit, and shrink fit. Now you know what are the different types of tolerances you need to give to the components so that these can sit in the assembly in the appropriate position. These are very important as far as design of a product is concerned. Well, you know how to do this one, but this also poses a challenge of what we call it as tolerance stack-up. What is this tolerance stack-up is all about? Let's take an example of a gearbox to demonstrate this functionality of tolerance stack-up. Now what you see on the screen is a worm and a worm wheel gearbox. Now if you see that there is a dimension which is controlling the position of these two shafts here, 35 mm. Now this 35 mm is very important because the two shafts have to be positioned accurately so that the function of the gearbox is not affected. Now this 35 mm is controlled by many different dimensions and the tolerances which you give to different components in the assembly. For example, the tolerances you have given for this particular bore, which can go up and down based on the tolerance level, and also the position of this hole can also be affected because of the tolerances. Now this also affects the position of these shafts. Not only this, the bore can be out of concentricity from the position of this particular flange here. So many different things affect the position or the two shafts here. So in SolidWorks we have a nice tool called Tol Analyst. So this is going to help you to do this tolerance stack-up without any pains. So how do we do this in SolidWorks? What you need to do is just to tell the system what is the sequence of assembly in your gearbox, and you also tell which are the primary and secondary tolerances which are going to control this positioning. So if you specify all these things, SolidWorks is going to give you a nice beautiful result where it is going to tell you what is the maximum and minimum stack up of tolerances, values of tolerances. It also gives you the RSS minimum and maximum. Not only this, it also tells you which are the tolerances which are contributing maximum to the stack up of the overall tolerance buildup. Based on this, you can take a decision which tolerance I need to control so that the overall tolerance stack up or the tolerance limit can be controlled. So this is a very quick and easy way of doing it in SolidWorks, which helps you to do it faster compared to the conventional method of putting everything in an Excel sheet and calculating the overall stack up. This becomes even more complex if you are working on a very complex assembly where there are a lot of parts involved in it and it's working on a 3-dimension. So this is a day-to-day industry challenge which you would face when you start building your own product or designing your own product. So this is an easy to use tool, very quick, and you can solve this problem within no time. That's what is Tol Analyst all about. Let's move on to the next industry challenge of design for manufacturability. Well, you would have learned very little about this in your academics, but this is an important factor in an industry, design for manufacture. If you are not designing the product which can be manufactured, then it results in escalation of cost, rework, and wastage. So this is a big problem in the industry. So design for manufacture is very, very critical, and every component has to be designed for manufacture. Now, what are the things? Let's look at some examples of design for manufacture. One is the drill size versus the depth of hole. If the hole size is very small and the depth of the hole is very long, this results in the drill bit being broken. This is one example. Another example we can talk about is the corner radius when you do a turning operation. Can this radius be manufactured in my industry setup or my manufacturing setup is a question. So we need to design products which can be manufactured in our industry setup, or it can be manufactured. Any type of 3D model can be designed or modeled, whatever comes to your mind, but can it be manufactured is a question. So we have a nice tool in SolidWorks, what is called as DFM Express, which helps you to create a template and define all the criteria that fits your manufacturing setup, and then you can check the components, each and every component, whether it is conforming to the standards what you have specified in design for manufacture. So this is an easy to use tool which tells you upfront whether this part has got some discrepancy with respect to the manufacturing ability what is available in your factory. This is what is design for manufacture. This is another challenge in an industry which everyone faces. Let's move on. Another challenge what the industry faces is design for least cost. Why should we design for least cost? One is company wants to make more profit. They are looking at profit margin. Another one, they want to be staying competitive with respect to their competitors. Now these two are most important factor, and cost plays an important role to achieve these two. We have a nice tool in SolidWorks what is called as SolidWorks Costing, which helps you to compare costs of different design variations. For example, if you change material of a same part, how does it affect my cost? This can be calculated. And if you change the geometry, how does it affect the cost? Can also be calculated. And what if I change the manufacturing process is also another requirement, and then you want to find out the cost for different manufacturing processes for the same component, then you can do that as well. In SolidWorks Costing, we have a nice template which can be built, and you can specify the criteria based on which you want to check each and every component for the cost. You can specify the manufacturing processes, what is the cost involved, what is the cost of material. All this can be fed and kept as a template, and then you can apply these templates or this particular criteria to every component what you design, and this is going to tell you the overall cost of this particular part or assembly. Not only this, it also helps you to compare the cost of giving it to different vendors. So this is a very quick and easy method of doing it. A primary responsibility of any mechanical engineer is to ensure that the proposed design will function as intended, safely and reliably for the prescribed design lifetime, and at the same time compete successfully in the marketplace. Success in designing competitive products while averting premature failure can be consistently achieved only by recognizing and evaluating all potential modes of failure that might govern the design of a machine and each individual part within the machine. There are many modes of failure in a machine. One of them is fatigue failure. In metals, fatigue is caused by repeated cycling of the load. It is significant because it will occur due to repeated loads below the yield strength of the material. You can see the graph here that shows how fatigue life or the life increases with decrease in stresses. Let's look at the graph here, which shows the stress versus the number of cycles to failure. Now this shows that at lower stresses, lower alternating stresses, the cycle is extended, and for every material this SN curve is available, which you can use it for predicting the failure. But how do we do this in SolidWorks? Now let's take an example of a real life case. In this case, I'm going to consider an automotive suspension system. So what you see on the picture is a double wishbone suspension system of an automobile. You all know that this suspension system is subjected to repeated loading or random loading due to undulations in the road. What is the typical way to do this one? The ideal way to do this one is to take an external data or do a physical test, bring the physical data into the system and then apply it to the assembly to predict the failure. Now what you see on the screen is a load history curve, which is nothing but the loading pattern taken out from a road test, and this is applied to the simulation or to the assembly, and then the fatigue failure is predicted. The system within no time tells you what is the total life of the particular component based on this type of loading. Now this integrated CAD tool with the CAD tool helps you to do the fatigue simulation very quickly, and also helps you to do the necessary changes in the CAD design so that you are able to evaluate what is the lifetime of a particular component so that you can design it for the specified period without failure. So this is an important criteria in an industry situation where you come across many different cases, not only in automobile industry, but you come across this fatigue simulation in many different industry segments, which is very important to do as far as any machinery is concerned. Reducing design time is another important challenge always faced by the product designers. Many times a conventional method or process may be very time consuming. One such example I can think of is a cam design. You would have learned how to do a cam design in your engineering. For example, for a particular motion, you do a displacement diagram and then measure those distances and then plot it on a circular shape and then derive what the cam profile. You know how to do this one. But in case of an industry, when you walk into an industry, the same process can be applied, but it may be time consuming if you have to do the design much faster. So how do we use the software, or how do we use SolidWorks to do this one? In SolidWorks, what you do is you model that in 3D, make all the components in the assembly, make the assembly function as per your requirement. The motion can be derived, or the motion can be achieved by giving the input to the motion, input to the mechanism, what you have designed in the software. So how do we give the input as motion to this particular assembly is by different methods. One is by using expressions or using data points or writing an equation, or many different ways with which you can give an input to a mechanism and make the mechanism work the way you want it in the software. Once you run this mechanism, you can trace the tip of the follower to derive the cam shape automatically. So if you see in the picture there on the left hand side, you can see the cam profile being sketched on the circular component there. Now using this, you can cut off the material and create the cam shape very quickly. So this is a very easy to use application where you can design your cams very easily and also accurately. Another very frequently used design theory is balancing of masses. This is very critical in all rotating machinery or where there are rotating bodies. Out of balance forces leads to increase in bearing loads, introduces stresses in rotor, and also introduces vibration and noise. Care should be taken to keep the imbalance to the minimum or balance it with suitable substitute of masses. You would have learned this theory of out of balance force, which is m r omega square, where m is the mass, r is the radius at which the center of mass is located, and omega is the angular velocity. Theta is the angle at which it is located with respect to a reference plane. For equilibrium, the vector sum of all the forces must be 0. This is theory of balancing of masses as you know it. How do we handle this in SolidWorks? Let's have a look at it. A typical example I can think of is an IC engine of an automobile. As the piston reciprocates, there is an imbalance of cyclic forces at the crankshaft. Imbalance is also added due to imbalance of masses in the crankshaft itself. We need to find the total imbalance in the mechanism and minimize it. That's what is our goal here. Again, SolidWorks Motion comes to our rescue and helps in plotting the reaction forces on the bearing of the crankshaft. This helps us to find out at which instance during the motion there is an increase in or decrease of forces. With this, designers can do the necessary changes to the design and calculate the imbalance of forces in the mechanism. You can see in this picture where the graph shows the magnitude of force as the crankshaft rotates. What is good about in SolidWorks Motion is that the joint definition of the mating parts are automatically taken based on the assembly mates which you have used to build the assembly, helping you to design faster and also calculating the imbalance of forces very quickly. This definitely helps you to reduce the design time and come out with your design very quickly. Optimized design is another industry challenge which is very important. Every product that you design has to be optimized for its defined function. It cannot be over designed or it cannot be under designed. So optimized design is very, very important. Product is optimized for its defined goals like strength, for its material, for the loads it can carry, for its safety and cost and weight. So you need to optimize the design so that these goals are taken care of. Sometimes product is also optimized for using a standard parts so that the cost can be brought down. Products are optimized for a specific life so that your product does not work beyond the specified period, as sometimes technology becomes obsolete beyond that period of time. So let's take an example here of how we can optimize the design. In this case, we have a medical examination couch where we need to design the couch in such a way there is an actuator which experiences the least forces. We need to locate the actuator in the right position so that it has the least forces, number one. Number two, we need to use a standard actuator. Number three, we need to modify these dimensions so that the position of the actuator is mounted properly or located properly in the entire mechanism. At the same time, the height of the couch has to reach a particular distance. It should not go beyond that, or it should not reach at a lower level. Now these are the goals and constraints with which you need to design this particular product and come to a conclusion. Now with all these constraints and variables, arriving at a solution is going to take a very long time in a conventional method. So every design variations you need to work out and then find out whether it is right or wrong. So if there are too many variables and constraints, to do it much faster, you need to use the software tool to arrive at the optimum design.
This complex design situation is easily handled with SolidWorks Motion Optimization. Here we can specify 1. Which are the dimensions and parameters to modify and its range within which it can change as variables. 2. What are the constraints within which it has to do these changes. And 3. The goal of minimizing actuator load. All this can be given as input, and the software does multiple iterations or design variations to achieve the goals set. This process is so fast and accurate that if otherwise, doing such an exercise will be too tedious. Another area I would like to discuss that involves a complex design challenge is the area of fluid dynamics. Let's consider a centrifugal pump that is widely used in many industrial segments. A centrifugal pump is one of the simplest pieces of equipment. Its purpose is to convert energy of an electric motor or an engine into velocity or kinetic energy and then into pressure of a fluid that is being pumped. The energy changes occur in two main parts of the pump, the impeller and the volute. The impeller is the rotating part that converts driver energy into kinetic energy. The volute is the stationary part that converts the kinetic energy into pressure. Liquid enters a pump suction through the eye of the impeller. When the impeller rotates, it spins the liquid sitting in the cavities between the vanes outward and imparts a centrifugal acceleration. As the liquid leaves the eye of the impeller, a low pressure area is created at the eye, allowing more liquid to enter the pump inlet. Centrifugal pumps are classified into three main categories: radial flow pumps, mixed flow, and axial flow pumps. To design a pump, we need to calculate the efficiency of the pump, where it is the ratio of power input to the power output. Head of the pump, which is governed by the equation H is equal to P1 minus P2 by rho g plus V by 2g, where H is the total head developed, P2 is the pressure at outlet, P1 is the pressure at inlet, rho is the density, g is the acceleration of gravity, and V is the velocity at the outlet. Also, the power output is governed by the equation P1 is equal to rho g HQ by nu, where P1 is the power required, rho is the density of the fluid, G is acceleration due to gravity, H is the energy head, Q is the flow rate, and U is the efficiency of the pump.
Though these can be done through hand calculations, the challenge lies in determining what shape of the volute that is needed to get the required pressure at the outlet. This is difficult with hand calculation. This is achieved with ease in SolidWorks flow simulation. Let's have a look at it and how we can do this in SolidWorks. The 3D model of the pump is quickly modeled and is done in SolidWorks, and fluid region is automatically identified by the system. Other input like inlet volume, flow rate, outlet atmospheric pressure condition, wall roughness, angular velocity of the rotating regions are all given as input. SolidWorks solves this problem and gives the pressure data at the outlet, velocity and other flow parameters. Using this, equations can be written to calculate the head and efficiency, which are derived by the software automatically. Flow trajectories can then be plotted and visualized, and a report can be automatically and quickly generated. So with this, we are able to arrive at the right design quickly without much of hand calculation. The software is going to help you to do this very fast. So this is quite a complex analysis where a conventional method of hand calculation is not going to help you much. Software is going to help you to do it and achieve the results much faster. SolidWorks has many functionalities that can be used in learning the concept of engineering. At the same time, the skill sets that the students learn are easily and effortlessly used in solving industry challenges. To demonstrate the fact that SolidWorks simulation solution is accurate, we have included NAFEM's benchmark problems in the validation example under the help menu in SolidWorks. NAFEMS, which stand for National Agency for Finite Element Methods and Standards, is a vendor neutral, non-profit membership association of more than 950 companies from all over the world. Members range from major corporations such as Boeing through mid-sized companies and to small consultants. The document that is given along with your software contains selected NAFEM's benchmark problems. These benchmarks demonstrate the accuracy of SolidWorks simulation software for the analysis modules of linear statics, thermal, geometric and material nonlinearity, and linear dynamics. You can use this to learn the concepts of engineering, at the same time apply this in the real world example using SolidWorks. SolidWorks is present in all industry segments. There are more than 1.65 million users and around 152,000 customers worldwide. Many companies from large, medium to small companies have adopted SolidWorks for their product design. These companies have implemented SolidWorks successfully to meet their design goals. Students coming out of colleges can rely on their skills in SolidWorks to embark on their journey into this globalized industrial world. This brings us to the end of this presentation. Thank you for joining me and have a good day.